Hello students! So this video here is about parallel lines and transversals with equations. So in our most recent video we discussed what transversals were and again what types of special angle pairs get formed when we have lines that get intersected by a transversal. Now, in this video, we're gonna look a little deeper into that, and we're gonna talk about what specifically happens when we have parallel lines that are intersected by a transversal, and we'll also look at certain equations that we can solve when we have this. And guys, not only is this involving parallel lines and transversals, it's still going back to where we discussed those other basic types of angle pairs like adjacent angles, vertical angles, linear pairs, and supplementary, complementary. It's still involving those types of angles as well. But anyway, guys, let's go ahead on and get started and let's do this. Okay, so let's give you just a little bit of background information that you'll need. So, guys, a plane. This is a word that you may hear, and I want you to be familiar with what it means and how they look and whatnot. So, guys, a plane is represented by a flat surface that extends without end in all directions. And guys, a plane contains infinitely many lines and it has no thickness. Again, folks, a plane is represented by a flat surface that extends without end in all directions. So if you're looking at this diagram over here to the right, with this green flat-looking surface that extends in all directions, you see the arrows extended in all directions, without end in all directions. It contains infinitely many lines because we know that lines don't have any thickness, and lines extend in both directions. Two-dimensional figures that extend, or flat figures that extend in both directions and has no thickness, right? So again, a plane contains infinitely many lines and has no thickness. And again, it's a flat surface that extends without end in all directions. All right, so guys, again, you will hear the word plane when we're talking about parallel lines. So I want to make sure you know what they are and everything. All right, guys, we can name a plane in two different ways. The different ways you can name a plane is you can use a capital letter, which will usually be positioned in what looks like a corner. Why do I say in what looks like a corner? Because, folks, we just said that a plane doesn't really have any corners because a plane extends in all directions forever without any end. So if it keeps on extending forever and ever, forever, I don't know who that was. Anyway, if it extends forever and ever and ever, then it doesn't have any real corners. All right. So, but again, with what looks like a corner, so you may use a capital letter that looks like it's positioned in a corner, unaccompanied by a point. And what we mean by unaccompanied by a point is you will not see a point like literally like a real physical like visible point right beside it. Okay, not to say that there aren't actually points all around it, but you won't see like a visible point like what you see with these other ones here on this diagram, where you see point A and it's visible, point L and it's visible. You don't see a visible point beside that capital letter P. That's the one I'm talking about. Okay, that capital letter like that's in that corner, or what appears to be a corner for the plane, and again is not written with a visible point beside it. All right. So again, that's one way you could name this plane. You could name it plane P. Another way you can name a plane is you can use at least three. And guys, when we say at least, we mean three or more. So at least 3 points in the plane, or on the plane, in the plane, on the plane, right? You can use at least 3 points in the plane that are non-collinear. When we say non-collinear, folks, we mean that those 3 points or 3 or more points, if they're non-collinear, that means that they do not lie on the same plane. If all 3 or more points are non-collinear, that means that they do not all lie on the same line. Okay? All right, so again, folks, that's a little background information on plane. When we're discussing when we're discussing parallel lines, you'll hear a word in that definition that's related to planes, and so that's why we went over what a plane is. Okay, and like for real. Okay, I ain't wasting your time or my time. You need to know. Okay, so guys, again, as I mentioned before, when we're looking at parallel lines, and again, this is a good opportunity here to go ahead on and make sure that you know about some other different types of lines as well. And these are not all of the types of lines that there are out there in the whole world, or in geometry, in Euclidean geometry, whatever. You may not know what Euclidean geometry is, whatever. It was it's okay. He was a mathematician. But anyway, so again, here we'll talk about 4 types of lines. But again, this video is mainly focusing on parallel lines. But guys, there's some information in here that you need to know, that you'll be expected to know, that you will see again. So yeah, like I said, just because this video is mostly focusing on parallel lines doesn't mean that this stuff here isn't important for you, because I'm telling you some information that you're going to see again. So trust me, if you see it in the future and you be like, oh man, I never heard of this before, or I never saw this symbol before. Yeah, that's not true. Not if you have Mr. Starkey. That's not true. And I'm not saying that I'm covering everything, my students who are enrolled in my classes at our school, but I am trying to let you know what you're going to see in the future. Anyway, guys, these four types of lines, parallel lines. Let's start there. So, guys, parallel lines never, ever cross. And guys, they will stay the same distance apart from each other. Guys, I know that the only one of these that actually says the word coplanar, as you can see right there, that word, you see the word coplanar? Yeah, that's related to the word plane, right? That we just now talked about. But again, folks, all 4 of these lines, or all 4 of these types of lines are coplanar. And guys, what we mean by the word coplanar is that they are in or on the same plane. All right, in or on the same plane. Now, I've heard both of those different prepositions used, in and on. Yes, I know what a preposition is. Just because I'm a math teacher don't mean I don't know some English terminology. Anyway. All right, so again, parallel lines never cross. They stay the same distance apart. They are coplanar, and they have 0 points in common. Yes, folks, all of that is included in the definition of parallel lines, even if there are multiple sentences there. Yes, okay. All right, we're going to come back to the other parts of parallel lines, but let's look at the other types of lines here. Intersecting lines. We've already talked about intersecting lines, how they will cross or meet or pass through, but they will meet at the same point. They will cross each other. Technically, that point that they pass through is what we talked about as an intersection, a point of intersection. Again, they will have 1 point in common. That's that point of intersection that we talked about, or that intersection, if we're talking about lines that intersect each other. All right. Perpendicular lines are types of intersecting lines that intersect at right angles. And again, we'll look a little bit more at the perpendicular lines as well, even in this lesson, so that you recognize certain symbols and things like that accompany that you'll need to recognize when you have perpendicular lines. Yeah. Another type of lines are coincident lines. Coincident is just another fancy word to pretty much say that you got pretty much two lines that are really the exact same line. Okay, really there's the exact same line, or at least the graph of the lines are going to be technically the exact same. All right, the equations of lines might look different, and for those who know what we talked about with equations of lines, we talked some about equations of lines. If we didn't go into detail in this class, you did in a previous course. All right, but again, the equations of the coincident lines might look different, but the graphs of them are pretty much going to be the exact same line. All right, and when you're dealing with coincident lines, they will have an infinite number of points in common, right? Because we know that a line has an infinite amount of points. So yeah, so if they're technically the same line, or at least if the graph of them is the same line, then they'll have an infinite number of points in common. All right, okay. So guys, most of us are familiar with what parallel lines are, with what they look like. But again, folks, there may be some information here that you need to know. Listen, okay? I don't care if you think you know it all. You probably don't. Guys, when you see two lines that look like they're parallel, do not assume that they are parallel. Okay? Just because they look like they're parallel doesn't mean that they are parallel. If you want to know for sure that they're parallel, you'll need to see some symbols on those two lines to let you know for sure. For shizzle. Okay, I don't know where that came from, but you'll need to know for sure. To know for sure that those two lines are parallel. Okay, I don't like that. That's too thick. All right, let's do that. All right, you may see some symbols on matching symbols on those two lines that sort of look like little arrowheads. Like a little symbol like that. It could be like one little arrowhead, or it could be like two little matching arrowheads. Right? If you see little symbols like that, those are symbols that are meant to let you know that these two lines are parallel. Guys, okay, yeah, I don't like to have that circle. I don't like the way that looked. All right. But those symbols there will let you know that two lines are parallel. Parallel symbol. All right, they may look like that, guys, or hold on real quick. Or they may look like, give me 1 second here, just 1 second. Or they may look alike. They may look alike. Yeah, that's how you know I'm tired. They may look like a different type of arrowhead. Like this. They may look more like, wow, really? Did I ask you to do that? They may look more like a filled-in triangle. Yeah, they may look like that, where they're matching like this. All right, but if you see it like this, and they're matching like that, and they're not actually on the end of the line, like. If they're not located somewhere like on the end of the line, you get what I'm saying when I say the end of it, right? But they're located somewhere in between there, not actually on the end of it. You know what I mean. Even though lines don't technically have an end, y'all know what I mean. All right, but these are symbols, and again, it could be more than one of those little arrowheads like that. But as long as they're matching on both lines, if they sort of look like little arrowheads like that, those are parallel symbols that let you know those two lines are parallel. You will need to see that on diagrams, folks. And guys, another symbol that you need to know for parallel lines is like it sort of looks like this. Sort of looks like two absolute value symbols that are right beside each other. So where it may look something like that, line AB is parallel to line, y'all get what I'm saying? It's parallel to line CD. or something like that. These two symbols, this symbol right here that sort of looks like that. That's another symbol that may be used to describe parallel lines. These are important for you to know, folks. Very important. Like I said, you might know what parallel lines sort of kind of look like, but you need to know about what I'm telling you right now. Okay, I'm not wasting your time or my time. It's important. You're gonna see them. All right, and you need to know what these symbols mean. Okay, all right. You hear me? You listening? Okay, because again, these are parallel symbols right there. That's what they are. Those are definitely parallel symbols that you'll see. Some of them are symbols you'll see on diagrams, and some of them are just symbols that'll be written to let you know that you've got two parallel lines, like what you see here. These little thingies right there. That line AB is parallel to line AB. I hate writing it like that. I'm not gonna write it like that because that's just too much. Line AB is parallel to, try to write that, is parallel to line CD. Yeah, that's sloppy. All right, so again, when we see those symbols like that, and you see that in this little diagram where it has line AB is parallel to line CD, okay, that's what they mean. Or it could say like line L. Okay, now usually folks, usually if they've got the name of a line as written as a italicized lowercase letter like line M is parallel to line N, yeah, they usually won't write the name of, or they usually won't write the word line in front of it. That's what I'm trying to tell you. Especially if they're showing you a diagram that goes along with it, yeah, they probably won't write the word line in front of it. It'll just look like that. Line M is parallel to line N. Y'all get what I'm saying? Y'all get what I'm saying there? Line M is parallel to line N. So those symbols, that's what that means, okay? And you will see that. So that's why I'm going over it, okay? Because it is important. That's why I'm placing so much emphasis on it. You hear the emphasis in my voice. You hear it? Okay. All right. That's enough emphasis. All righty. Folks, another symbol that you will see, that you will surely, sure enough see, even if not in this particular lesson, but another symbol that you'll see. Now, we said the perpendicular lines intersect at right angles. We've already talked about the right angle symbol, like when you see, again, when you see two lines, or when you see an angle, and they want to sure enough identify and label that angle as being a right angle. You'll see that little right angle symbol there that looks like a little box inside of that angle. Okay, that's one way to know that you've got perpendicular lines. If you see two lines and you've got that right angle symbol there, that lets you know that those two lines intersect at a right angle. Okay, or those two lines intersect, forming right angles. Okay, or 90-degree angles. Right now, another symbol that you'll see that can let you know that you're dealing with perpendicular lines. It's that symbol sort of looks like, you see where I got this thing right here, and you see that little yellow, where I got this little yellow spot right there? Okay, good, awesome, lovely, great. I'm glad that we're not blind. Wonderful. All right, that symbol there, it sort of looks like a capital T upside down. Okay, I don't want to take up too much time talking about this, but again, it sort of looks like an upside down capital T. That is a symbol that can be used to let you know that two lines are perpendicular. This is a perpendicular symbol. Looks like an upside down capital T. It's a perpendicular symbol that lets you know that two lines are perpendicular. All right, and guys, from here we're going to go ahead on and get into the lesson of what this is actually about with parallel lines and transversals and those special types of angle pair relationships that are formed only when those two lines are parallel. So guys, in our last video, in our most recent lesson, we discussed different types of angle pairs that get created when we have lines and the transversal. We talked about corresponding angle pairs. We talked about alternate interior angles, alternate exterior angles, consecutive interior angles, or again, we said another name for consecutive interior angles is same side interior angles. We talked about how when we have lines, two lines that get intersected or cut by a transversal, those types of angle pairs are formed. Okay. Now, in this lesson, we're going to discuss specifically what those relationships will be for those types of angle pairs when your two lines are parallel. All right, so let's go ahead on and get into the meat of this right here, the steak and potatoes. Steak and potatoes. All right. Okay. All right, so guys, here, let's sort of get into the meat of this lesson here. So guys, right here, these are the relationships when two parallel lines are cut by a transversal. So guys, these postulates and theorems here, they let you know exactly what you should expect to see with these angle pair relationships. And guys, I don't know who spelled that word right there, relationships. Trust me when I tell you, I didn't type that out. I know how to spell relationships. You see what I've written out, I spelled it correctly. If I noticed the typo, I would have corrected it if it was something that I typed and if it was something that I could correct. But anyway, I didn't type that. Just so you know, Mr. Starkey does know how to spell. I might not have been a spelling bee champion, but I know how to spell. Anyway, so these are telling you what relationships these types of angle pairs have only when the two lines are parallel. Okay? So guys, these types of angle pairs get formed regardless of whether or not the lines are parallel, but there are only certain relationships that will happen only when your two lines are parallel. And that's what we're talking about right now, okay? When the two lines are parallel and they get cut by a transversal. All right. So guys, when we have corresponding angles that get formed when two parallel lines are cut by a transversal, then those pairs of corresponding angles, folks, are going to be congruent. So your pairs of corresponding angles. And guys, here I've just got a little, I tried to pick an image that sort of shows you and reminds you of what those corresponding angles sort of look like that are in matching positions, right? So again, I tried to pick a little image over here to the side that kind of reminds you that these are corresponding angles in matching positions. Because first, guys, if you're going to use these postulates and theorems, you need to be able to look at a diagram and identify what type of angle pair you are looking at. Yes, there is so much emphasis in my voice because it is so important. Folks, you got to be able to recognize what type of angle pair you're looking at. Which is why I spend so much time just going through the terminology and showing you how it looks and what they are, what the definitions are, and things like that, because it is so important. It is beyond tough to do the math if you don't know the definitions and terminology behind all of this and how all of this stuff looks and how to recognize it. It is so hard to do if you don't recognize it. All right, so waste. All right, so those are corresponding angles. Again, folks, when you got two parallel lines cut by a transversal, the pairs of corresponding angles will be congruent. All right, next, alternate interior angles. If you got two parallel lines cut by a transversal, then, folks, those pairs of alternate interior angles will be congruent to each other. Yeah, that is beyond sloppy, but you can tell what that looks like. Yeah, it's congruent. At least it fixed it. All right. So again, folks, over here I got a little diagram reminding you of what alternate interior angles look like, right? Not only is it there in this diagram where they say to the left here where they say angle 1 and angle 2 are wait, that's the wrong one. Where they say angle 1 and angle 3 are congruent because they're alternate interior angles, and they tell you that angle 2 and angle 4 are congruent because they're alternate interior angles. I got a little separate little diagram over here to remind you again what alternate interior angles look like, so you're not confused, okay? You shouldn't be confused, but again, to help remind you again, folks, that it's very important for you to be able to recognize what they look like, so that you can use these theorems and postulates that I'm going over right now when you got two parallel lines that get intersected or cut by a transversal. So you'll know that if they're corresponding angles, that they'll be congruent. If they're alternate interior angles, and that they'll be congruent. But again, when you have parallel lines that are cut by a transversal. Anyway, moving on. Consecutive interior angles, and again, we know that another name for consecutive interior angles is same side interior angles, right? So when we have two parallel lines that are cut by a transversal, then each pair or any pair of consecutive interior angles are going to be supplementary. Well, folks, what do you know? We've talked about the word supplementary and what supplementary means, right? Yeah, supplementary angles add to 180, right? So when we have two parallel lines cut by a transversal, whenever you have consecutive interior angles, though the relationship between those consecutive interior angles is going to be that pair is going to be supplementary. Or in other words, that pair of angles, the measurement for them is going to add to 180 degrees. All right, and so we've got a little diagram here to remind you of what consecutive interior angles look like, or same side interior angles look like, where they're interior angles that are on the same side of the transversal. And again, that's to remind you of what they look like. You see that right there? All right, goody. I'm glad you see it. All right, okay. And the last type that we talked about that is specific to when we have transversals and lines is alternate exterior angles. So folks, when we have parallel lines, two parallel lines, I can't emphasize enough, only when we have parallel lines that are cut by a transversal, because that's what this whole lesson is about, is exploring and letting you know what happens with the relationships here when we have parallel lines that are cut by a transversal. All right, so you hear me emphasizing it so much, okay? I'm not fussing or anything like that. Just trying to make my point of how important it is. When you got two parallel lines that are cut by a transversal, all right, then each pair of alternate exterior angles is congruent, okay? All right, so folks, you see so far the ones that I got with the congruent parts here. Okay, so those three. Okay, when we got parallel lines that are cut by a transversal, these three corresponding alternate interior and alternate exterior, those three types of angle pairs will be congruent when we have two parallel lines that are cut by a transversal. Guys, the one type of pair that will not be congruent that we've talked about when we have transversals, the only pair that will not be congruent, listen, the only pair that will not be congruent when we've got parallel lines that are cut by a transversal is going to be that pair that you see here, consecutive interior angles. The consecutive interior angles will be supplementary. All right, I thought it was going to do my little circle, oval, whatever you want to call it. All right, well, maybe it ain't going to do it. I don't know. I tried. I'm trying to get it to do it. It just acting like it won't do it. Give me 1 second. Ha! We got it. We got it. All right. So again, the only one of those four types of angle pairs that will be supplementary where the angle measurements will be supplementary when we have two parallel lines that are cut by transversals. The only one of those pairs that will be supplementary is the consecutive interior angles. And folks, maybe one way for you to remember that. I always think of that one there, supplementary. I think of the fact oops, give me a sec. I think about the fact that I can't say the word consecutive. You see how that has that S in there? Consecutive. You hear that? You hear the S sound? Supplementary. Consecutive. You hear that S sound? Supplementary. Consecutive. The S sound in that. I can't say the words consecutive without saying that S sound. Consecutive interior where it has that S. It has that S. Consecutive, supplementary, right? I can't say or write that without it having that S in there, right? Supplementary, consecutive. That's one way that's how I originally started remembering that. And of course, I know it by heart. You know, I'm a math teacher. But anyway, that's how I originally started remembering that was the one pair here that is not congruent. Okay, that's supplementary. That adds to 180. And again, guys, remember another name for consecutive interior angles is same side. There we go again. You see that S, same side. Consecutive, supplementary. You get that? The S in there. That's one way that might help you to remember that this is the one pair out of those four that is going to be supplementary when we have two parallel lines that are cut by a transversal. All right, but anyway, folks, that's the relationship that happens when we've got two parallel lines and a transversal. That's what happens between these types of angles. When we've got parallel lines and transversal. Guys, next we're going to look at some examples to help you do the practice with this. All right, examples coming right up. Okay, guys, right before we go into and look at some of these examples, again, folks, I cannot emphasize enough how important it is for you to be able to recognize these types of angle pairs. I've got these extra diagrams here, folks. Anything that I've got here that could help you, folks. Again, I'm not there with you in person. I cannot force you to take notes. But can you take notes? Sure you can. You got hands, pencil, paper. Sure, if you decide to, if you feel like it's going to help you, and I suggest it. But again, folks, I can't emphasize enough how important it is for you to be able to recognize these things when you're looking at them. Because it's going to be beyond hard for you to try to do these problems that I'm asking you to do if you can't even identify the basics here of identifying what type of angle pair this is. Okay, if you can't tell me that you're looking at an alternate exterior angle pair, then you're not going to be able to tell me that the two alternate exterior angles are congruent when you've got parallel lines that are intersected by a transversal. But anyway, folks, again, I can't emphasize it enough. I just can't. Okay. Anyway, next up, examples. Okay, so let's look at this example here, guys. So let's look at this. All right. It says here, classify each pair of angles as one of the following: alternate interior, corresponding, alternate exterior angles, vertical angles, supplementary angles. Right. Now, guys, when it says supplementary angles here, now they don't have any angle measurements here, right? So if they don't have any angle measurements written there, like specific angle measurements, like 35 degrees or anything like that, they don't have angle measurements here, then remember, folks, we've talked about linear pairs, right? We've talked about a linear pair and what linear pairs are and what they look like, right? Linear pairs are two angles that form a straight line. Any two angles that form a straight line is a linear pair. And what do we know about the measurements for two such angles like that form a straight line like this here? When they form a straight line, because a straight angle has what measurement? 180 degrees, right? And so if these two angles here add to give you 180 degrees, that means that a linear pair is also what? Supplementary. Great. I'm glad you know that. Wonderful. Because that's part of the basics that we need to make sure that you got, that we tried to explain to you in previous lessons. All right. Yeah. I might have to move that over. Yeah. And I'm sorry. I apologize about the sloppiness there. I really do. Ran out of space to write that. My bad. All right. So they are also supplementary. So again, folks, when they say supplementary angles, again, if you can identify those two angles as being a linear pair, linear line, linear pair, they form a straight line, and a straight line or a straight angle is always 180 degrees. If you can identify them as a linear pair, then that's good enough for saying that they're supplementary. Okay? Alrighty, I'm going to go ahead and erase this because I want to have a little bit of room here if I decide to write something else. I'm going to erase that right there. All right, lovely, awesome. Okay, all right, angle 9 and angle 16. All right, so angle 9 and angle 16 are, do you recognize what types they are? Okay, do you recognize that these are the two lines here? And that this other line, where that other line at? That this other line right here is the transversal. So, again, angle 9 and angle 16 are, oops, yeah, that's just a sloppy. Okay, well, I thought it was going to erase that. I guess it ain't going to erase it. Okay, that's just crazy, but all right then. All right, number 9 and number 16, angle 9 and angle 16 are, well, y'all know what that say. I'll erase that afterwards. Angle 9 and angle 16 are both, wow, okay, that's why, because it was erasing the words that I had written there. That's why. All right, well, that's fine. I'm still, what? That is so confusing. All righty, anyway, angle 9 and angle 16 are both are both exterior angles, because again, you should recognize that that these two angles are not in between those two lines. They're not in between those two lines, and they're on opposite sides of the transversal. They're not adjacent, and they're on opposite sides of the transversal. Now, folks, do I have enough time to go back through what adjacent angles are? Probably not. So if you need a refresher on what adjacent angles are, and to make sure that you know that these two angles here are not adjacent, yeah, you probably want to go back and look at those previous lessons, that previous video, to make sure that you know exactly what adjacent angles are. Either that, or you use my contact information. You contact me. We can get us a little session in here, and we can help you out. Okay. My students enrolled in my classes, because y'all got my contact information at our school, right? Anyway, so again, these two angles are alternate exterior angles. All righty, great, lovely. All right, we're going to move it on along here. Alternate exterior angles, part C. Let's erase all of that. I mean, every last little bit of that right there. Get rid of all of that. Lovely, awesome. All right, so that one was alternate exterior, which is C. Okay. Number 2, 15 and 11. Okay, so these two angles, angle 15 and 11. Oops, if you look at those two angles there, they form a straight line. You got 11 right here, and you got 15 right there. They form a straight line. Well, guess what? Those two angles, 11 and 15, are a linear pair. And if they're a linear pair, because they form a straight line like that, that means that they add to 180 degrees, because any straight line or any straight angle is 180 degrees. that's sloppy, but guess what? You can read what that say. If you can't, you can hear what I'm saying, and you can hear that I'm saying that it's 180 degrees, which means that it's supplementary, right? Awesome, because it's a linear pair for number 11 and 15. All right, so they're supplementary. They add to 180. Awesome. All righty. These got to be E, supplementary. Okay. All right. There are also adjacent angles, but anyway, that's not one of the choices that we've got here. All righty. Let me erase all of that because I don't like the way that looks either. Get rid of all that. Bye-bye. So long. Farewell. See you later. Sayonara. Adios. Au revoir. Alright. That was supplementary. Alright, number 10. Angle 10, angle 15. Angle 10 and angle 15. That one. I said that one and this one. That one and this one. Alright, both of these angles are interior. They're both between these two lines. They're interior. They're on alternate or opposite sides of the transversal. All right, so they're both interior. They're on alternate sides of the or opposite sides of the transversal, and they are not adjacent. They're not right beside each other. They don't share a common vertex or a common ray. So these two angles here would be considered alternate because they're on opposite sides or alternate sides of the transversal, alternate interior angles. Okay, so these two angles here are alternate interior angles. Angle 10 and angle 15, alternate interior angles. All right, I'm getting rid of all of that. All right, they're alternate interior angles. And that's A, that's an answer choice. All right, number 4, angle 12 and angle 15. All right, we got to hurry this on along here. All right, angle 12, angle 15. That one and did wait. I said did one. That one and did one. Those two are vertical angles. Okay, so those two angles are vertical angles. And again, folks, just a little quick reminder. Again, vertical angles are those types of angles that are not adjacent, that are across from each other, facing opposite directions, like that. And so that's what's happening with these two angles. They're vertical angles. They're not adjacent. They get formed when two lines intersect. And again, we don't have time to go over the basics of what we already tried to show you and tried to explain to you in previous lessons. If you need help with that, you can either contact me. I'm talking to my students enrolled in my classes at our school. You can either contact me, or you can look back at some of those previous videos, or you can find your own resources online. Find some other videos, YouTubes, some other websites that explain it. But again, there we go with that one there. But again, we have shown you or tried to show you that in previous lessons. Alrighty. Alright, so those two are vertical angles. Alright, angle 9, angle 11. Angle 9 and angle 11. These two angles, they are what we call corresponding angles. All right, so first off, they are pretty much in the same position. The position for angle 9 is like an upper left. I know the difference between left and right, y'all. It's like an upper left. It's in like that upper left corner for this set of angles. Okay, you guys remember playing sort of like a game, like 4 squares, 4 corners, whatever, where you like toss the ball from one corner to another. There's 4 people in 4 corners. Anyway, this one here would be like the upper left corner, right? And in the other set of angles that you see there, angle 11 is in that same position, in a matching or corresponding or matching position. Matching position. Upper left, matching or corresponding position, right? So again, these are corresponding angles because they're in corresponding or matching positions. Angle 9 and angle 11 are both in a upper left matching corresponding position. Okay. Alrighty, so they're corresponding angles. I'm getting rid of all of that in the diagram. Bye-bye. So long. Farewell. All right, again, there are corresponding angles. All right, I'm trying to put a whole lot of emphasis on this because, again, folks, it's very important for you to be able to identify what types of angle pairs these are. All right, we haven't even gotten to really the stuff with the equations yet. All right, but anyway, all right, identifying these 9 and 15. Okay, so guess what, folks? 9 and 15 are not any of those types. Okay, that's none. Okay, don't really have a whole lot of time to talk about why it's none of them, but again, it's none of them. Okay, it's not any of those that are there. Okay. Not corresponding, not alternate interior, not alternate exterior. They're not supplementary. Yeah, or at least there's no way for us to definitively know that they're supplementary. Okay, but anyway, angle 13, angle 14. All right, let me get rid of that in that diagram. Okay, good. These here, none. Angle 9, angle 15. Angle 13, angle 14 in the diagram. Again, folks, those two angles there, they form a straight line. They're a linear pair, right? And again, for any linear pair, a straight angle, if the two angles form a straight line or straight angle, they form a straight angle together or a straight line together, they add to 180. They're a linear pair. They make a straight line, right? Add to 180. They're supplementary. Great. Awesome. Supplementary. All right, I'm getting rid of all of that in that diagram. These two are supplementary. No, not that one. Really? Really? This was none. This was supplementary. All right, great. All right, number 8, 14 and 11. All right, angle 14 and angle 11. These two are alternate interior. And again, folks, one way that I said you could sort of kind of look at alternate interior angles is sort of like a little Z kind of shape. But again, I explained that again, if you are looking at those types of angles and it looks like they're the type of angles that get formed in sort of like a little Z shape like that, then you could think of them as alternate interior angles. Like these two angles right here would be alternate interior angles. Like these angles here would be alternate interior angles, right? If we had two lines that get intersected by a transversal, right? Okay. Y'all can see the two lines and a transversal. Okay. All right. I ain't just making something up here. It's like two lines and a transversal. All right. Awesome. Anyway. All right. So again, angle 11 and angle 14 would be considered alternate interior angles. All right. I'm sorry about how sloppy that looked. Okay, but I'm getting rid of all of that. I did try to explain that to you guys, my students enrolled in my classes, in our previous lesson about that. All right, so let's see here. Again, angle 11, angle 14 are alternate interior angles. Okay, all right, now let's look at some actual examples dealing with angle measurements. And really, this is sort of even before we look at equations. Okay, all right, so guys, let's look at this one here, and let's look at what we got going on right here. All right, so in this thing here, first off, let me just kind of explain, just kind of real quick. Well, no, that's okay, not that way. Okay, go back. All right, so guys, when we've got these two lines here, and you see the symbols there that say line S is parallel to line T. So they're telling us that these two lines, line S and line T, are parallel. Okay, and so let me just sort of make sure that you guys know that there are two different transversals there. One of the transversals is line M, okay? Line M there is one of the transversals, and line N, as in Nancy, is the other transversal. And guys, those transversals are not parallel to each other. Line M and line N, they're not parallel to each other. So, folks, you're going to need to sort of look at those two transversals separately, okay? And you're going to need to look at the angles that are formed with those transversals separately. So that's why I'm drawing two separate diagrams here, because we're going to need to look at them separately. So you'll kind of need to ignore one of the transversals for you to look at one of them. All right, so let's see. They give us angle 2, right? Angle 2 is with that transversal line M. Okay, so angle 2 has a measurement, according to them, has a measurement of 67 degrees. So the measurement of angle 2 equals 67 degrees. That's more than enough information for us to fill in all of these angle pairs here up in this diagram that I've drawn here that you see right here. Okay, right there. That one right there. That's more than enough information for us to fill in the information for all of the angles in this diagram there, in that part of it. Okay, for this transversal. Okay, for the transversal M. All right, so guys, first off, out of these 8 angles that you see here, there are 4 of them that are going to have the exact same angle measurement, 67 degrees. 4 of them that are going to have that exact same angle measurement, right? So first off, guys, there's an angle measurement that is vertical with angle 2. And so, guys, what I'm putting right now is a congruency mark. Okay, so that angle that's vertical with angle 2, because we know that vertical angles are congruent, or vertical angles have the same measurement, right? So that one clearly has a measurement of 67 degrees. All right, which other ones are going to have a measurement of 67 degrees? All right, so angle 2 and this angle right here, okay, angle 2 and the angle 10 are corresponding angles. Angle 2 and angle 10 will have congruent angle measurements, because one thing that we literally just now discussed here, is just to remind you, was that when we got 2 parallel lines that are cut by a transversal, each pair of corresponding angles are going to be congruent. All right. Okay, so again, angle 2 and angle 10 are corresponding to each other. Angle 2 and angle 10 corresponding angles. Yes, they are. And so that's why angle 10 would be 67 degrees. And guys, the angle that is directly across from angle 10, that would be a vertical angle with angle 10. That angle would be 67 degrees as well. All right, so those 4 angles that I've got circled in green right here, the 10, angle 10, angle 11, angle 2, angle 3, angle 2, angle 3, angle 10, angle 11. All 4 of those angles will be 67 degrees. All 4 of those angles will be 67 degrees. Okay? All right, some of them because they're vertical angles, like angle 2 and angle 3, and some of them because they're corresponding angles, like angle 2 and angle 10, right? Okay, great. Again, folks, if you still need to make sure that you know how to identify these types of angles, if you still don't get what I mean when I say that angle 2 and angle 10 are corresponding, then I I think you got a little bit of studying to do, because I got more than enough information in these videos to help you figure out and learn this information. But again, if you need help from me, my students enrolled in my classes, feel free to contact me using the contact information I've given you, and also feel free to look up this information on your own if you don't feel like I'm giving you enough information. But I'm sure that I am giving you more than enough information to be able to get a great understanding and understanding of this. And again, if you do need help from me, you know how to contact me. Okay. All right, so all four of those angles are 67 degrees. So guess what? We know that angle 3 is 67 degrees. Let's go ahead and write that in. Any of those other ones? Okay, angle 10 we know is 67 degrees. All right, so right now, those are the only ones that we were asked for that have a measurement of 67 degrees. Okay, so again, all four of those angles that I have circled in green are 67 degrees. Guess what? These other angles that are in this diagram right here that I got sort of kind of selected. Those other angles are easy to find. Excuse me, because if we know that angle 2 is 67 degrees, all these other angles in that diagram, since we have parallel lines, all the other angles are in that part of it are going to be supplementary to 67 degrees, right? Like for instance, angle 1 and angle 2. So angle 1 and angle 2 form a straight line, right? The 67 degrees and where you see angle 1 there, angle 1. They're supplementary because they form a straight line. So again, they should add to give you 180 degrees. So folks, now if you don't know how to figure out what's left over from 180 degrees, think about money then, okay? You got $180, okay? And you're going to spend 67 of it. How much money you going to have left? I know you know how to figure that out, don't you? Don't you? Don't you? All right, anyway, folks, if these two angles have to add to 180 degrees, just figure out what's left over. And again, if you don't know that relationship, then I think you need to study some more to know that these are a linear pair, and to know that linear pairs are supplementary, to know that supplementary angles add to 180. Anyway, these have to be equal to 113 degrees. All right, so all four of these angles, angle 1, apologize if that looks sloppy, angle 9, angle 4, and angle 12, all four of those have to be 113 degrees. It's going to work the exact same way, guys, with our other transversal. All right, we got to hurry up if I want to show you guys at least some examples dealing with transversals, with equations and everything. Yeah, we're going to have to hurry up because I got about a good 18 minutes left. All right, so let's see. Out of those, which ones did we have? All right, angle 9 is 113. Wow, really? It's 113 degrees. Let's hurry that up. Okay, yep. Nope. All the other ones are in the other dot. Okay. All right, so let's do this real quick. Angle 6 was 93 degrees. Let's go ahead on and fill that in. So these ones that I have circled in blue, all four of these would have to be the same angle measurement. 93 degrees. 93. So excuse me for not writing it all in, but I got it color coordinated for you. So again, all four of these angles would have to be 93 degrees, okay? That's color coordinated. Now, if you don't recognize your colors, I can't really help you on that one there. But these here, these angles that are blue, or if you're colorblind, I don't know. I can't really help you on that one there. But again, these ones that are blue, and I'll write it here just in case you're colorblind. Oops, except I wrote it in the wrong place. Give me a sec. 93. I'm really not trying to be funny here. I'm really not. Just in case, I don't know. I don't know who out there might be colorblind. I don't know. All right, so those four are the ones I'm talking about right there. That's color coded in blue. All right, anyway. All right, so that's angle 7. It's 93 degrees. And okay, that's all of the ones that they asked us for with that. The only last one there is these ones. So if we know that this is 93 degrees, okay, these other ones that are right beside it are going to have to be because they form a straight line. So again, folks, because they form a straight line like that, and I hate to write it all like this with it looking all sloppy like that right there, but I ain't got much of a choice. So with that being 93 degrees and this from here being angle 5, this has got to be equal to 87 degrees. All right, because again, if they form a straight line, they're supplementary. They add to 180 degrees. Okay, so all four of these angles here that I got in this funky looking purplish type of square, all four of those would be 87 degrees. So that includes angle 5. Yeah, we got to hurry this up. Yeah. Ooh, okay. I might have to make a second video for this if I want to include a few more examples, and that might be okay. Yep. All right, so folks, that's this example here where we were given these two angle measurements, and I hate that I jumbled that up with this other with this other diagram. Give me one sec here. Okay, all right. So just so that you can tell the difference between this example that we just did and that last one. All right. I'm gonna try to do maybe one or two more examples in this video, and then we may have to also do another video for you with this, so you can see all the types of things here, because we really haven't even had a chance to go into the equations part of it. But again, we will. Okay. Little example coming right up. Okay, guys. So this example here, they tell us that the measure of angle 1 is 3x plus 15. All right, here's an example that has variables in it where we'll have to write out equations to go with it. It tells us the measurement of angle 2 is 4x minus 5. Then it tells us that the measurement of angle 3 is 5y. That the measurement of those is equal to that, okay? All right, so, folks, here's the deal. All right, first off, you probably don't want to do anything with a part that has, you probably don't want to try to do anything with the x's and the y's. If you can, try to do something with the parts that both have the x in it, right? So the parts that both have the x in there is angle 1 and angle 2. So folks, and we gotta hurry this up because I gotta get out of here. I don't want this alarm to get set on me. Angle 1 and angle 2. Those two angle pairs, and I apologize if this begins to look sloppy, guys. I'm short on time. Those two angle pairs, angle 1 and angle 2, are corresponding angles. Wow. Let's try that again. Are corresponding angles. And so again, folks, when we have parallel lines, and we know that these are parallel lines because we see these parallel symbols, right? Those matching little arrowhead type of symbols on the line that lets us know that our lines are parallel. Line R is parallel to line S, and we know that line P is parallel to line Q. Okay, so again, we've got those parallel symbols there that let us know that we're dealing with parallel lines. Okay, yeah. All right, so again, these two, angle 1 and angle 2, are corresponding angles. Guess what? We said when we've got corresponding angles, when we've got parallel lines and a transversal. And folks, just so you're not confused, with angle 1 and angle 2, if you had to focus only on the three lines that are forming angle 1 and angle 2, those three lines that are forming angle 1 and angle 2 are line R. Oops, that's sloppy. A line R. Yeah, that's still sloppy, but it's all good. As long as you recognize that that's a 1, folks. I don't really care about it being sloppy. All right, line R, line Q, and line P. So, folks, again, those are the three lines that are forming angle 1 and angle 2. And again, with those three lines, angle 1 and angle 2 are corresponding angles. And so again, folks, corresponding angles are going to be congruent when we have parallel lines with the transversal. So again, folks, I'm gonna write out here what we're trying to explain to you in this video is that when we've got two parallel lines that are cut by a transversal, that corresponding angles are congruent. And again, this is only with parallel lines, and we got to hurry up. We got to hurry up. All right, enough to finish up this video. All right, so guys, if these corresponding angles are supposed to be congruent, then we can write out an equation. Congruent means that they're the same measurement, right? If they are the exact same measurement, or in other words, if they're equal, same measurement equal, then you literally set those two equal to each other. So we write out 4x minus 5 equals 3x plus 15. Let's hurry this up. Really, seriously. Plus 5 on both sides. Equals negative 10. Subtract 3 on both sides. Sorry if it's starting to look sloppy, guys. But we got to go ahead on and finish this up. We got to wrap this up right now. X equals negative 10. Yep, because that canceled out, that canceled out. That's x equals negative 10. Wonderful. Awesome. All right. Ooh. Okay. Yeah. Did I write something wrong? 3x plus 15, 4x minus 5. I don't think I wrote anything wrong. Let's make sure I'm not tripping. 1 and 2 are corresponding angles. Yes, which means that when you set them equal to each other, yes, because they're congruent. All right, I got to hurry this up. 5 minus 3, yeah. That was what it was. Plus 15. No, I was adding 5. Yeah. Okay. Yeah, I'm not tripping. That's, x equals negative 10. All right, so apparently x equals negative 10. Sure. Okay, fine. Yeah, I don't really believe that, but okay. All right, yeah, guys, I didn't come up with this problem. Seriously, but yeah. That would actually cause these angle measurements to be negative. Yeah, I didn't do all of that. All right, guys. The measure of angle 2. Okay, I'm gonna have to stop this here. Yeah. Measurement angle 2 is 4x minus 5. If you plug in what we just now got there for 10, you wind up getting here that this angle 4x, that's 4 times negative 10. Ooh, I gotta really hurry this up here right now. Yeah, I gotta be done. Minus 5. That is negative 45. Apparently, yeah. Whoever made this problem made this be negative. So apparently the measure of angle 2 is negative 45. Guys, angle 2 and angle 3 are corresponding angles. Yeah, I got to be done right now. Angle 2 and angle 3 are also corresponding angles. So if angle 2 is 45, then angle 3 is 45 degrees or negative 45 degrees. All right, I got to be done right now. 45 degrees equals 3y. If you divide by, that's 5y. If you divide by 5 here, then that is going to give you 9. And technically, since that was negative 45, this is going to give you negative 9 as your y value. All right. So Yeah. All right. Bye. Bye, guys. Gotta go.